You know how I've been dating Corrine forever?
Yeah, you've been dating her for neons.
Yesterday, we got engaged.
Wow. Hey, do you know Calcium's going to be eating here today?
Really? Cool. Hey, hasn't he been working through lunch for like a month ever since he broke up with Carbon? I haven't seen you in ages.
I heard that you were talking about me and Carbon. Well, I've moved on. I think I'm going to ask Chlorine out later today. What?
Chlorine and I just got engaged yesterday.
What? No, we're perfect for each other. She'll fall in love with me for sure.
You'll never be happy with her, though. Because you have 2 valence electrons.
How dare you think you know more about me? Who says everyone wants to be like you, Xenon?
No one. Some elements want to be like helium and have 2 valence electrons. That principle is called the duet rule.
Ignoring those elements, what makes you think everyone wants to be like you?
Actually, not everyone else wants to be like me. Atoms just want to be like a noble gas with the closest atomic number. This means that, except for the elements that follow the duet rule, most atoms want to follow the octet rule. That is, they want to have 8 valence electrons.
And why is it that atoms follow these rules?
Because that's what makes them the most stable, with a few exceptions.
Maybe I'm one of those exceptions, then.
But you're not.
You were just trying to get me distracted. Why don't you agree that Chlorine and I were meant to be together?
Well, actually, since you mentioned that, and then...
Where did you get that?
I always keep a periodic table handy with me. See, Calcium, I live here on A1 Street, so that means I have 1 valence electron. You live on A2 Street, so you have 2 valence electrons. The 3A, 4A, 5A, 6A, and 7A, that's where Chlorine lives, and then 8A, that's where Xenon lives.
And the transition metals?
The only way to know their electron configurations for sure is looking them up.
You've proved nothing. Face it, you're stalling and you don't even have an argument.
Hey, I'm not finished explaining it.
You're just trying to get me off topic.
Just give them another minute, Calcium. You group 1 and group 2 metals can be so overreactive sometimes.
Okay. Anyways, so when we elements form friendships, we do one of 3 things. We give electrons, we share electrons, or we receive electrons. A group of friends, everyone ends up with the same number of electrons as the closest noble gas.
How do you decide whether to give, lose, or share electrons?
That's determined by something called your electronegativity. That's an indicator of how good you are at taking electrons. For example, my electronegativity is 0.9 and your electronegativity is 1.0.
So you're just trying to say I'm too greedy to be her metal friend?
No. You wouldn't gain electrons anyways, and besides, gaining electrons isn't a bad thing. For example, I have 1 valence electron and Chlorine has 7. So if I give my 1 valence electron to Chlorine, she'll have 8, and then I'll also have 8 valence electrons from the previous energy level.
Who says I have to have 8 valence electrons? I can be happy without 8.
Oh, maybe he has a point, Sodium. That's what Boron said when he became friends with the fluorine triplets. Now Boron seems stable.
But boron and the fluorine triplets are bonded covalently, and besides, that's just a weird exception.
Maybe you're right about this 8 valence electron thing. You still didn't answer my question. How do they know whether to give, take, or share electrons?
It all depends on how different your electronegativities are. If the electronegativities are close enough, then you'll all share electrons, like a covalent bond. If the electronegativities are far enough apart, then you'll bond ionically, which means the metal will give valence electrons to the non-metal. The metals in that relationship are called cations, and the non-metals are called anions. The cations are then positively charged, and the anions are negatively charged. Friendships between metals and non-metals are usually ionic, because metals and non-metals usually have very different electronegativities.
You prove nothing. Face it, you're stalling and you don't have an argument.
No, I'm not finished explaining it.
You're just trying to get me off topic.
Okay, moving on. Okay, see, Calcium, this means that you want to lose 2 valence electrons. Over here, this means that I want to lose 1. And over here, where Chlorine is, you can see that she wants to gain 1 valence electron. So if I gave my 1 valence electron to her, then she'd have 8 valence electrons because she already had 7, and I'd have 8 valence electrons. because I'd have 8 valence electrons from the last energy level. However, you'd still have 1 valence electron left, which is why you'd never be happy with chlorine.
Well, if you're just going to keep on talking about why all of my potential non-metal friends and I don't have chemistry, then maybe I can eat my plum pudding at some other table.
No, you can still have a stable relationship.
With whom?
With someone like oxygen, or sulfur, or selenium.
I guess I'm still not over my breakup with carbon. Thanks for putting up with me, guys.
So you're still not mad about me and chlorine?
You know, she wasn't really my isotope anyways.